Uh, Welcome to ABMS final project presentation. Our topic is about emergency evacuation under terrorist attack scenarios. We try to make the model as close to as the real world scenario. Starting from the model, the world in which the model is placed. Here as you can see, it's a floor plan of a real life building. We made it feasible such that any person having a blueprint of a model can simply give the picture of the model and we can try to replicate the same model in the NetLogo. Here, as you can see, with the help of Python and NetLogo tools, we converted a floor plan image into a ABMS model. And the same model we are using here. It is a floor plan of a shopping mall. Now, as you can see, there are some green stripes which we termed as exits, and there are yellow stripes which are important because they are exit signs. They will direct you to where an exit is present. Now, there are three types of agents in our model. The first one is terrorists, the second one are civilians, and finally the third ones are rescuers. The terrorist function is simple. Try to kill as many people as possible. So the terrorists will simply see a civilian and go to the civilian and kill them, chase up them and kill them while avoiding obstacles. Next, the civilians. Modeling the civilians is quite tricky as there are different types of civilians, some who know where the exit is. Here, we mark the civilians who know exit is with purple color. All the dots you see in purple color are the persons who know where the exit is. And the persons who always try to stay as a family, stay in a group, and always try to stay connected as a group from the starting. We made them in the orange color to observe the grouping scenarios and whether it would help in the emergency evacuation scenarios. And finally, the blue ones are the normal ones who don't know where the exit is, but they try to follow their neighboring ones to get to the exit as possible. As soon as the simulation starts, all persons will try to get to the exit point as soon as possible. The purple agents who know the exit, who have the knowledge that they will go right away to the exit point, avoiding obstacles using breadth first search, which we implemented. And those who know exits, who don't know exits, when they see the boarding signs, when their boarding signs is in their vision range, will know where the exit is, and they also, like purple agents, will try to rush. And there will be so many people who do not know where the exit is and will try to just mimic or just go in the direction as the rest of the crowd in the neighborhoods. And finally, the orange people will have a leader, the leader of the group, and he will direct the whole group where to go, and the whole group follows him. And the rescue people will try to protect as many people as possible by giving them signals about exit. That means where the exit is. Whenever the person is in the vicinity of a rescue people, he knows the where the exit is and will be given directions on where to go to reach the safe zone. And rescue people have another more function. When he comes in the vicinity of a terrorist, they both fight off and only one will survive. We use probability such 50-50 chance such that only one survives when they two come in close contact with each other. And the yellow stripes will help as a exit signs to help people to move to the exit. Yeah, we perform this emergency evacuation under various scenarios and using various terrorist strategies such as will be shown now. Starting from the circle in the middle, terrorist starting at random, terrorist starting at the exits. We analyzed our various scenarios and found that having exit signs is useful and it helped save more people during the evacuation. We also found that grouping behavior is actually helpful in the emergency evacuation as due to the grouping model, some people are very less vulnerable to the terrorists. And we also found that presence of rescue people improves the survivability rate very highly. And this is our model. I would like to show a small demo. And this is here the blocking of agents. As you can see, every person is trying to go through, go to the exit, and the terrorists are trying to kill the people, and the rescue people are trying to send as many people to the exit by giving them directions. And this is the end of the model. As you can see, out of 1651 people, nearly 1100 people reached the safe zone. And finally, the results. We ran our simulation under various conditions, such as stampede and no stampede situation. We found that with stampedes, obviously, the number of survivors are very less when compared to without stampedes. And number of people who reach the safe zone under various strategies. We found that having directions to the exits placed on the walls and grouping feature and presence of rescue teams has helped the survivability of the civilians much more uh, when compared to having no help. And we also found that similarly that more people are killed when having no additional help, and more people are survived in the presence of directions to the exit and in the presence of rescue teams. And we also found that when terrorists start their attack at the exits, the more people are likely to die. So the effective terrorist strategy, which is dangerous, is the exit strategy when terrorists are present at exits, and these all are placed in info tab, as you can see. And the number of people killed at exits and terrorists are present at exits is very high. Thank you.
Hello, my name is Vikram, and my roll number is 20. So I have implemented the following functions. One is to set up exit signs. These are exit signs which are in yellow color, placed at random coordinates with p type equal to sign. And then I have also implemented to reach safe zone function, uh, which lets you know that whether the particular civilian is in the safe zone or not. Then to check stampede function, this function lets you know whether the particular agent will get involved in the stampede, or if he gets involved in the stampede, then how much blood he will lose. And then to check death, this is used to check whether the person is dead or not, and to increment the stampede counter. Next, to follow signs. This function actually helps the user if he sees a particular sign in his vision range, then he will gain the knowledge of the exit path. Thank you.
Good evening, I'm Abhishek. My roll number is 3. I worked on the following functions for the project. The first function I worked on is the setup groups. Setup groups is where it is essentially a family or a group of friends who usually move together. So with a certain probability, a group leader is assigned and a group of size 5 is created. So all of these group members try to follow one person who is assigned as a group leader. And the other function I worked on is setting up the terrorist strategies. One is random movement, the other is placing the terrorist setting their camp at each exits, and the other one is the terrorist staying in the center at a certain radius. And I've also worked on uh, the group following its leader. So we keep track of all the path in which the leader moves in. So we keep track of all the directions, and if there are no obstacles in between, all the members of the group move towards the leader, the same that as which the leader moved in.
Hello sir, my name is K. Sataraj Vinil, roll number 74. This is my individual contribution for ABMS and evaluation. First function I wrote is a setup world, which takes a mall layout and creates an environment accordingly using import p colors. And second function is setup exists, which creates the exits for the world created. Next function is kill terrorist, which is a rescuer's method. It targets a terrorist and finds if if the terrorist can be killed, or else there are walls between the rescuer and the terrorist. Uh, if there is no terrorist also, if there is a wall, it will bounce back from the wall. Next are two verification functions for verifying the setup. First one is verify setup, where I will check for the whole environment, whether all the walls and everything, signs and exits are created and agents are created properly. And next will be the verify blood distribution function, which verifies the distribution is created correctly as mentioned by the inputs for the civilians blood. Thank you.
Greetings of the day. This is Saurabh Petkar, roll number 142, and this is my contribution in the ABMS project. The first function is BFS function, the breadth first search function. What this function basically does is it calculates the distance for every patch from the nearest exit. The second function is the setup rescuers. This function places the energy commandos at different places. Third function is the rescue movement. This function is executed by each and every rescuers in order to protect the hostages and kill terrorists as well. Fourth function is the no path function. What this function basically does is it is executed by all the hostages, and it basically tells the best patch to go in order to go to the exit. That's it. Thank you.
This is Lakshman and this is my code. I wrote the setup civilians thing, which is like placing civilians where there are no walls and making sure that only the percentage given of them knows where the exit is. And I also wrote this code, which is the civilian movement, which I'll show in a bit. Yeah, civilian movement. Civilian movement is basically the strategy of how civilian move to reach the exit zone, and the direction movement also to keep up the individual's direction where it is heading. And finally, I also wrote the terrorist movement, which I'll show you now, just now. Yeah, this is the terrorist movement. Yeah, yes. Thank you.